Hey everyone, in this video I'm going to show you how I built this DIY spot welder using a 12-volt car battery and a solenoid-based control system. So first, the power source. I'm using an old 12-volt car battery that a friend gave me. Even though it's old, car batteries are actually perfect for spot welding because they can deliver extremely high current for a very short duration. And that short burst of high current is exactly what we need for spot welding purposes. Now, instead of directly connecting the battery to the welding probes, I added a solenoid-controlled circuit. I purchased this circuit from AliExpress. This control circuit actuates the solenoid based on an adjustable intensity setting, which ranges from 1 all the way up to 199. So what does that intensity means? Basically, it controls the pulse duration. In other words, how long the current flows to the welding probes. So if I'm welding thinner material, I can use a lower intensity. If I'm welding a thicker nickel strip, I can increase the intensity. So this gives me flexibility depending on the type of material I'm working with. Now for switching the high current, there are generally two approaches: electronic switching using MOSFETs or mechanical switching using solenoids. So MOSFET based designs use semiconductor devices to control the current very precisely. But since I am working with car battery that can deliver massive current instantly, I preferred a solenoid. It's basically a heavy duty electromagnetic switch that physically connects the high current path when energized. So because of that, it's more rugged and can tolerate high current spike better in a simple DIY setup like this. For this project, the solenoid felt safer, more durable and easier to implement without needing complex driver circuits or heat management. One thing I noticed is that when the solenoid energizes, it produces a strong mechanical jerk. So I mounted the entire solenoid assembly onto a solid wooden base. That helps me absorb the vibration and prevents the unit from shifting during operation. For wiring, I use thick battery cables from the battery to the solenoid and then from the solenoid to the copper welding probes. Using heavy-duty gauge wire is very important because thinner wire would cause voltage drops and reduce welding performance. For the welding tips, I use copper spot welding needles. I added heat shrink tubing to isolate and shield them, leaving only the tips exposed. This reduces the risk of accidental short circuit and making handling safer. Now, a very important safety recommendation: I strongly suggest adding an appropriate high current fuse between the battery and the solenoid circuit. Car batteries can dump extremely high current instantly if something goes wrong. A fuse adds an extra layer of protection in case of accidental short circuits or component failure. Let's talk about testing. I tested this spot welder on a 18650 lithium-ion battery using a 0.2mm thick nickel strip. After adjusting the intensity properly, the weld came out perfect. The nickel strip bonded firmly to the battery terminal without overheating or burning through. But when working with lithium-ion batteries, safety is extremely important. Here are some precautions I followed. Never puncture, crush or damage the cell. Keep welding pulses short and controlled. Avoid overheating the battery. Always double check polarities. Never weld on damaged or swollen cells. Work in a well ventilated area and keep the fire extinguisher nearby just in case. Lithium-ion batteries store a large amount of energy and improper handling can cause fire or explosion, so please take safety seriously. Overall, I'm really happy with how this build turned out. If you found this project helpful, let me know in the comments, and as always, build safely, test carefully, and see you in the next project. Thank you.